All right, question number 5. We also have 8 parts here. So in the probability distribution to the right, the random variable x represents the number of hits a baseball player obtained in a game over the course of a season. We're going to complete parts A through F. So first we want to verify that this is a distribution. So I'm going to copy this. I'm going to do it in Excel. Again, just easier with familiarity. I'm going to add up the probabilities and just make sure that the sum is 1. So we get 1 exactly. Looking at all of them, they're all between 0 and 1. So those are the 2 properties we check first. So yes, all the probabilities are between 0 and 1. The sum of the probabilities is equal to 1. So that is the 2 properties we have to check for. If we try to match which one is the correct graph, the first one goes up to a height of 0.16. So that's at 0, we're at a height of 0.16, and so that's too low. That looks like about 0.16. That looks good. This is too high, and this is about 1.5. So B, just based on the first one only, looks close to 0. This distribution probably appears to be more normal. You can almost argue a skew to the right, but it's not as bad as the previous one. Looks like there's one mode. Again, there's just one high point. If the high point was even with 2 of them, we can say bimodal. But one mode, the one that shows up the most is 1. And I would say roughly symmetric. Again, you can argue skew to the right. I would generally always error roughly symmetric. So they don't like the symmetric. Let's just say skew to the right, and it looks like it has a tail on the right. So again, that one's kind of iffy. We want to compute the mean, so let's do the mean. I'm going to say equal. It's going to be the x value times the probability. I'm going to drag this formula down, and we're going to sum them up. I'm going to say mean. So 1 point, do not round, okay. So 1.6232. Of the following, which is the best interpretation of the mean? So this is the number of hits a player got in the course of a season. So over the course of many games, one would expect the mean number of hits per game to be the mean of a random variable. Note. Observed number of hits per game will be equal to the mean. Note. In any number of games, note. The observed number of hits per game will be less than the mean. I don't like either of those. Let me go back. Over the course of many games, one would expect the mean number of hits per game to be the mean of the random variable. So I guess that one would be the best after looking at all of the observations. Observed number of hits will be equal. A looks the best. The standard deviation, so we're going to do that again. I'm going to make one row that's going to be e of the x squared. So it's just like the mean. Just like the mean, except we're going to square x first. So I'm going to go right here. I'm going to say equal. It's going to be this number times itself, and then times the probability. And I'm going to drag that down once I do that first one. And I'm going to sum those up. Okay. Now that I have e of x squared and the mean, I just have to subtract e of x, take e of x squared, subtract the mean squared. So I'm going to say equal this e of x squared minus the mean squared. I think it will do it if I don't, if I don't put it in parentheses, because order of operations should multiply before we subtract. So this would be the sum, the part inside the square root. Now I have to take the square root of this. So I'm going to say equal SQRT this number, and that gives me, around the 3 decimal places, 1.16 1.178. What's the probability a randomly selected game, he got 2 hits, so this is the probability distribution. 2 hits will give us 0.2862. And F, the probability the player got more than 1 hit, so more than 1. So that means not 0, not 1. 1 would be equal to 1. More than 1 would be 2, 3, 4, 5. So I can add all of these up, or I can do 1 and subtract the sum of these two. But since it's a computer, it's easy just to kind of copy Control-C, just paste it Control-V, and I can just find the sum that way. But again, that's the same as 1, which is 100%, minus this one, and then minus, undo that. And then put equal. Equals 1, and I'll say minus this one, and then another minus, and then this one. So if you input that formula, you get the same number, 0.4953.